The idea that space is expanding in every direction can be difficult to wrap your head around. In everyday life, expansion usually means something is growing outward from a single point, like ripples from a stone thrown into a pond. But in cosmology, expansion works differently. It's not about objects moving away from a central location. It's about the fabric of space itself stretching everywhere, all at once. In the universe, galaxies aren't flying through space away from a common origin point. Instead, the space between them is increasing. From any given galaxy's perspective, it looks as though all other galaxies are moving away. An important detail is that this expansion doesn't make anything move closer together in other directions. Because the stretching is uniform, all distances between unbound objects increase at the same rate. There's no need for something to give way or get closer in order for expansion to happen. This behavior is described by general relativity, which shows that the metric, the way we measure distances in space, changes over time. The scale factor in cosmology grows, meaning that any 2 points in space get farther apart unless they are bound together by forces like gravity. And that brings up another key point. Expansion is only noticeable on very large scales. Within galaxies, galaxy clusters, and solar systems, gravity holds everything together so strongly that the stretching of space has no meaningful effect. The stars in our galaxy aren't drifting apart because the local gravitational forces completely overwhelm the incredibly weak effect of cosmic expansion. On the other hand, the space between galaxy clusters is where expansion becomes obvious. Over millions and billions of light-years, gravity's influence weakens, and the stretching of space steadily increases the distance between clusters. This is why the large-scale structure of the universe is made up of vast filaments of galaxies separated by enormous, ever-growing voids. It's worth noting that expansion doesn't literally stop within bound systems. In theory, space is still stretching everywhere, even between you and the chair you're sitting on. But on small scales, this effect is so minuscule that it's entirely negligible compared to the forces holding things together. So when we say space is expanding in every direction, we're describing a global property of the universe. It's a uniform stretching of the underlying fabric, not an explosion from a point in the middle. And it means that no matter where you are, you'll see the same overall pattern: galaxies receding, distances growing, and the cosmos continuing to evolve in every direction at once. In practical terms, that means cosmic expansion only changes distances where there's no strong gravitational or other binding force to resist it. Inside galaxies, stars remain in their orbits. Inside the solar system, planets stay locked around the Sun. Even the Andromeda Galaxy, despite the overall expansion of the universe, is moving toward the Milky Way because their mutual gravity outweighs the pull of expansion. So while the universe as a whole is expanding, it's not happening in a way that rips apart everything inside it. Instead, the growth of space plays out most clearly on the immense, intergalactic scales where gravity's grip has loosened, slowly pushing the largest structures in the cosmos farther and farther apart.